Origin's tolerance interval app includes an option for sample size calculations. This video covers the two options available under this tool. The first option calculates the sample size needed to achieve a tolerance interval covering a pre-specified minimum percentage of the population, while capping the maximum acceptable coverage. The second option determines the maximum acceptable coverage achieved for specified sample sizes. The engineering team is interested in monitoring variation around paper brightness. They believe that paper brightness, which is measured in ISO units, follows a normal distribution. In our first scenario, the team would like to calculate a two-sided tolerance interval that includes 90% of the population, while capping maximum acceptable coverage at 93, 94, or 95%. Open the tolerance interval app and select the sample size option. Under What to Compute, select Sample Sizes. Min percent of population in interval, 90%. Confidence level, 95%. Max acceptable percent of population in interval, 93, 94, and 95%. Probability of population coverage exceeds these values, 0.05. Select two-sided under tolerance interval. Click OK. The second table displays the results. We assume that paper brightness follows a normal distribution. With 582 pulp measurements, we are 95% confident that a two-sided tolerance interval covers at least 90% of the population, with a cap at 93%, and the chance of exceeding this cap is 0.05. The rightmost columns, non-parametric, exact confidence, and exact error probability, should only be used under the non-parametric method. Although not needed here, we can look at these results. Results from the non-parametric method are always more conservative, requiring a larger sample size, and producing an exact confidence slightly above 95% and an exact error probability slightly below 0.05. Let's take a look at our second scenario. The team would also like to know the maximum acceptable percentage achieved if they collect three different sample sizes, 40, 55, and 80 pulp measurements. For this, let's use the following settings. Select Max Acceptable Percent of Population in Interval under What to Compute. 90% for min percent of population in interval. 95% for confidence level. 40, 55, and 80 for sample sizes. Probability of population coverage exceeds these values, 0.05. And finally, two-sided under tolerance interval. Click OK. The second table displays the results. Under the normal method, with a sample size of 40, we are 95% confident that the two-sided tolerance interval covers at least 90% of the population, with a cap at 98.39%, and the chance of exceeding this cap is 0.05. Again, although not needed here, we can also look at the same sample size under the non-parametric method. With a sample size of 40, we are 92% confident that a two-sided tolerance interval covers at least 90% of the population, with a cap at 99.1043%, and the chance of exceeding this cap is 0.05. Notice that the exact confidence level of 92% is less than 95%, the nominal value specified in the input dialog. This indicates that a larger sample size is required under the non-parametric method. The next step is to collect paper brightness data and compute the tolerance interval. Book 1 contains the collected data. Origin offers two options for tolerance interval calculation, normal and non-normal. We will select the first option. In the input dialog, let's enter 90 for minimum percent of population in interval, 95 for confidence level, and select two-sided under tolerance interval. Click OK. The table 95% tolerance interval displays the calculated tolerance interval. Based on the results, we are 95% confident that at least 90% of paper brightness measurements fall between 79.34 and 88.14. In the normality test table, we show the results of an Anderson-Darling test to determine if the data follow a normal distribution. The null hypothesis is that the data follows a normal distribution. The p-value is large and we do not reject the null. If you aren't sure that your data follows a normal distribution or the other distributions supported by Origin, then it's best to use the non-parametric method. Under the non-parametric method, we are 97.629% confident that at least 90% of paper brightness measurements fall between 79.13 and 87.58. With the large sample size, results under both parametric and non-parametric methods are similar.